using function notation. So what's this equivalent to for year 9 course? That will be y equals to mx plus c, give you x equals to 1, y equals to 2, x equals to 4, y equals to 9, and find the equation. Okay, that will be exactly the same type of question as that. So this one is just using the function notation. Okay, instead of telling you what is x, what is y, find m, find c, it will give you in the function notation. So as what we learned last week, so function notation is just fx equals to something. So fx is instead of the y, and the x is just the value we're trying to substitute in the bracket. So if we can have a look for the first example, we have f is r mapping to r. Okay, r mapping to r means we have a domain, okay, r, have a domain r, and then we have function y equals to x plus b, okay, y equals to x plus b. So this gives you, okay, f1 equals to 7. That's exactly the same as x equals to 1, y equals to 7. So the thing in the bracket is the x value. Okay, the f bracket means y. So when x equals to 1, y equals to 7. So similarly, we have here x equals to 5, y equals to 19. Also, the fx equals to x plus b, we can treat it as y equals to x plus b. So then the question will go back to what you have learned before. Okay, that's the year 9 study, like year 9 course. We're trying to substitute value in, we're trying to solve them simultaneously, and we find the value for a and b. So for this one, we can do 7 equals to a plus b, and 19 equals to 5a plus b. So they are simultaneous equation. Okay, they are simultaneous equation. So if they are simultaneous equation, we can try to do either elimination or substitution. I will suggest if you can do elimination, just use elimination. Okay, so substitution will be quite complex. So I will use equation 2 to subtract equation 1. We have 12 equals to 4a, a equals to 3, then b will be 4. So fx is 3x plus 4. Okay, the first one is not hard. Okay, we just telling you some information and ask you to solve simultaneous equations. If you can have a look at example 2 and tell me what are those points. Okay, is that are they special points or just some general points? Or what? Well, because the first one already set up the rule for you. Okay, the rule is ax plus b, give you the equation, just ask you to solve for the variables. But for the second one, there's no equation involved. It just tells you that's a quadratic function. Okay, a quadratic function. So we can have 3 forms of quadratic function we learned last topic. We can have turning point form, we can have x-intercept form, we can have the general form. You need to select one to start with. Okay, I can't work from no equation. Even though there are 3 points, if you can see there are 3 points. Can you have a think what form is the best one to use? Which one is the best one? Which one? Turning point? General? Okay, turning point, general. Any other answer? Do you know why we need to use x-intercept? Is there any turning point involved? Well, I don't know. Maybe 0,16 is a turning point. Maybe the x-intercept is the turning point. I don't know that. I don't know that information. There's no information telling us we have a turning point here. So turning point form is across. No. Okay, I can't use turning point. I can definitely use general. I think the reason why you select general is because we have 0 equals to 16. That coordinates is a 0, 16. So if you use general form, you can directly have the C value, okay? But you still have two more values to solve, which is the A and B, okay? X squared plus BX plus C. So you still have A and B to solve. If you can see this, F4 equals to 0, F negative 2 equals to 0 as well. That's the 2x intercept. So it's 4, 0 and negative 2, 0. We have 2x intercept. Well, the preference is like first preference will be turning point 4, but there's no turning point. Second preference will be if I have 2x intercept, I will use x intercept form. The last choice we have no choice, then we need to select general. We try to avoid general form because it's too complex to solve for it. You can see if when you do your homework, the last question asks you to sub 3 points in to solve for the general form. It's really hard to do. So we can select the x-intercept form. So I can say fx. Okay. Use the new notation. So fx equals to a, x minus 4, and x plus 2. Okay, then we set up the equation. And we have 0 and 16, which is used for find the a value. So 16 equals to a, negative 4, and 2. 16 equals to negative 8a, a equals to negative 2. So fx equals to negative 2, x minus 4, and x plus 2. Because the question hasn't asked you to put it into the general form, so do not expand it. Well, when you expand, you may make mistake, okay? You may make mistake. So it not ask you to expand, so don't expand. Unless the question say, put into the general form, ax squared plus bx plus c, then you need to expand it. Otherwise, any form like quadratic form should be fine. Okay, that's the second one. So give you 5 minutes to do example 3 and example 4. Okay, 5 minutes, can give you 7 minutes, 2 questions. If there's no equation involved, you need to set up the equation first and then try to do substitution. Okay, for example 3, most of you choose to set up a linear equation y equals to mx plus c or ax plus b to solve for that, which is like a correct method. Okay, all good, nothing wrong with it. I'm just trying to give you another idea of how to solve this type of question. Well, just for this particular question, because it's a linear, and the two value given us is minus 5 and minus 12. 7 and 6. So this question is exactly the same of giving 2 points on the linear and asking what's the linear equation. So we don't really need to set up y equals to mx plus c, because we know if we have 2 points given on the linear, we can find the gradient first. Okay. We'll find the gradient first. So that will give me 6 minus negative 12 over 7 minus negative 5. The gradient gives me 18 over 12 divided by 6, 3 over 2. That's our gradient. Also, we know that we have this formula, y minus y1 equals to gradient x minus x1. Well, you can select the other points as well. You can select the negative 5, negative 12 points as well. I directly get this linear equation here. Okay, I'll directly get the linear equation here. So y equals to 3 over 2x minus 21 over 2 plus a 6. So 6 is a 12 over 2. So y equals to 3 over 2x minus 9 over 2. Okay, minus 9 over 2. Okay, so this is the linear equation now. Like that is the linear equation. So I'll prefer that I can write that into the function notation. That's the function notation. Okay, that's my working. So A says F0. So F0 is asking for the y-intercept. F0 equals to 9/2, which is you sub x equals to 0 in. F1 is 3/2 minus 9/2, which gives me, well, negative 6/2, negative 3. Okay. F1 is negative 3. So if we can put that into two coordinates, that's just 1, negative 3, and 0, negative 9/2. Okay, B says solve the equation fx equals to 0. Okay, fx is y. So basically asking you what's the x-intercept. So you change fx into 0. So what is fx? Here is fx. You change that to 0. So 0 equals to 3/2x minus 9/2. 9/2 equals to 3/2x. 9 equals to 3x. X equals to 3. So solve the equation. I have solved it. X equals to 3. That will be my answer. If we think about the x-intercept is 3, 0. Okay, x-intercept is 3, 0. Well, your method is nothing wrong, like you set up mx plus c or x plus b, and you subpoint in, trying to solve that simultaneously, solve a and b value. That's all good. Okay, if you can get the right answer, that's all good. But like for this one, we don't really need to solve simultaneous equation. We don't need to solve anything. We directly work it out by the previous knowledge. Find the gradient, use the y minus y1 equals to m, x minus x1 formula. I will keep like trying to make you remember this formula, trying to make you use this formula, because when we learn like finding tangent equations, we'll use this formula a lot. So trying to use that as much as you can. That's for example 3. Let's have a look at example 4. Okay, the volume of a sphere of radius r is determined by the function given by rule VR equals to 4/3 pi r cubed. This is a formula you require to remember. Okay, that's from year 10 measurement topic. So that's a formula required you to remember. So the volume of a sphere is 4/3 pi r cubed. Well, anyway, it's given to you now. State the practical domain of the function v. Okay. The domain is always referred to the thing in the bracket. Okay, that is the domain. If you are talking about domain, the domain is the thing in the bracket. It's not the v, okay? It's talking about the r. So that is the domain. It's the same as the x. Fx, we are talking about domain, we talk about the x, not the f. Okay? So they just ask you what's the practical domain of the this function. So I will say that I will write in the interval notation r belongs to, well, I will say round bracket 0 to infinity. I need to have a sphere. Well, you can include 0 by thinking, well, it's just a 0 volume. Okay, there's nothing left, it's a 0. Also makes sense, but I think if you really talk about there is a sphere, you need to have a sphere, we need to have some radius. So I'll say we can't take 0. Yes? Yeah, you can. You can just say r plus, that's equivalent. Yeah, they're the same. There's always more than one way to write it. If you can make sure that's right, then all good. You can write in multiple ways. So that's r plus or 0 to infinity. And we are asking what is V10. V10 means r equals to 10. What's the volume? Okay, find the volume when r equals to 10. So V10 just equals to 4/3 pi 10 cubed. That's 4,000/3 pi. I'll just leave the answer like that because it's asking for exact. It's not asking you to round it. So pi is the exact value. If the question hasn't asked you to round to 2 decimals or 3 decimals, you must keep it into the exact form. Doesn't matter how complex the answer looks like. You need to keep it as the exact form. So that's the exact form. I will just leave the answer like this. Any questions for this page? We just need to get used to the function notation, knowing where's the x, where's the y, what you need to substitute. And it's nothing really new to you. Okay, it's not really a new thing. R belongs to, okay. If we don't have any questions, let's go to example 5. Okay, this is a quadratic equation and with a k value, like I don't know the c value. For the first one, asking you, show that for all the k values, the minimum occurs when x equals to 5 over 2. Okay, so two things. The first is show that this is the minimum occurs at that. And second one is find the k value if the minimum is 0. When we talk about the minimum or maximum for quadratic, what is really asking? Like what we need to think about? Where to start if we talk about the maximum or the minimum for quadratic? Which point it refers to? Turning point. Okay. How we can find turning point for this function? How we can find that? Minus b over 2a. Well, yes, we can use that formula, minus b over 2a formula. But it's not something really, can you see the word show that? Okay, if you really want to show. Also, there's something talking about the minimum y value, like minimum y equals to 0 as well. Like also talk about the y coordinates as well. It's better to do it by completing square. Okay, it's better to do it by completing square. If we can complete the square and then show that the minimum turning point is this comma that, we can solve both parts easily. It's a little bit weak to use a formula to show that is always the minimum. So it's better by using completing square to do that. So first thing is, can you make that into the turning point form for me, please? Okay. Just do that. Okay. If there's other method, that's fine, but I want you to try to complete square first for this question. How you can complete square for, there's a coefficient. Coefficient is not 1 for x squared. Okay, coefficient is not 1 for x squared. What you can do. Alright. The first mistake is a really serious mistake. Okay, everyone needs to pay attention to that. So your fx equals to 3x squared minus 5x minus k. That is not equals to x squared minus 5 over 3x minus k over 3. Okay, that's not equivalent to that. You can't just divide the 3 for everything without any reason. Instead of doing this, you need to take 3 as a common factor and then put that together. Okay, so that's a common factor. Well, I will prefer, well, it's okay if you include the c value in. I will prefer to not include the c value in. I will just collecting the first two terms. That's enough. Well, I think it's easier for me because I need to expand the bracket anyway later. So I'll just leave the c outside. But you don't need to change your answer. If you include in, nothing wrong. And the next thing is, okay, I will add half of the b squared and I will subtract half of the b squared with the bracket and that. Okay, that's all happen in the bracket. Can you see there's a bracket? I'll make it into a square bracket. They are all in the bracket. There's a coefficient 3 there. Okay, coefficient 3 in front. So for the first 3 terms, I can complete square. But before I do that, I will still make the square bracket here to stay. Okay, the bracket just hasn't been opened yet. I'll make it stay there. And then this number is a negative 25 minus 36 already. Okay, leave it there. So for those 3, I can complete the square. That becomes x minus 5 over 6 squared. And don't forget your minus k at the back. Okay, a lot of you directly make the square bracket away. Okay, just no square bracket. Where is it? So pay attention when you take a coefficient out. The square bracket is still there. When you expand it, you need to times that. Okay, 5/6 squared minus, okay, you need to times this number by 3 and then minus k. Okay, that's the completing square form. Okay, that's the completing square form. If you want to put k as a whole fraction, okay, as a whole fraction, this is equivalent to minus 25 plus 12k over 12. It's a plus. It's not a minus anymore. If you have the minus in front, okay, it's a plus. Like the middle changed to a plus. Okay, because when you bracket that, this become a plus. So you plus it instead of subtract it. That's another mistake I realized. I'll put the minus closer to this. This is a really good question. I like this question because you can see so many mistakes when you do this question. So you need to know where you can make mistake and you're trying to avoid that. Okay, it's not bad to make mistake, but like remember your mistake and trying to correct it. Okay, so my turning point will be 5/6, comma, well, I would say negative 25 plus k over 12. This negative must be in the front of this whole fraction, okay, not on the numerator. You can put it in the denominator, but you can't put it on the numerator. Okay, yes. Oh, yes, thank you. 12k. 12. Okay, so when the first question asks you, show the minimum is always there, you will say, because it's a positive parabola, so the minimum value will be the turning point. Okay, then turning point is at x equals to 5/6. So the minimum always occur at x equals 5/6. Just make a little bit discussion because it's a positive quadratic. Okay, that's the main thing. If you have a negative quadratic, it's the maximum, it's not the minimum. So you say that's a positive quadratic, therefore the minimum always occur at the turning point where is x equals to 5/6. And it says that the minimum y value is 0. Well, it says the minimum value, but it's the minimum y value. Okay, even though it doesn't say y value, you know that's the minimum y value. So you make negative 25 plus 12k over 12 equals to 0. 25 plus 12k equals to 0. K equals to negative 25 over 12. Okay, that is when k is this value, you will have a minimum y value at 0. Then this graph should look like this. Okay, touching the x-axis. Okay, the graph should look like this. Just let you know, it's a perfect square. It's a perfect square. You only have one x-intercept. Where it's touching is that must be the turning point touching the x-axis. Okay, that's the first question. Let's have a look at B. Find the value, I would say values. Okay, instead of value, I would say find the values of k such that fx is greater than 1 for all real x. So for any x you put in, all the y value must be greater than 1. Okay, all the y value needs to be greater than 1. This is a very typical question. If you learn Spec, you will see more question like this type. Okay, it will be more question like this type. So it's asking you to think about all values. Okay, all the y values needs to be greater than a level. Then if it's all greater than one level, say level 1 here, which means your minimum point must be greater than that value. Okay, if you can satisfy your minimum point is greater than 1, then all the value needs to be greater than 1. Is that true? Or say if you have a upside down like the negative quadratic, you will have a maximum point. Then we will say all smaller than value, which just require your maximum value to all below a level, below a particular level. So for this question, it's just basically require us to have a quadratic that's the level 1. So your graph needs to be somehow like this. Again, not touching because it's greater than 1, which just need the minimum value to be greater than 1. Okay, the minimum value to be greater than 1. So basically we have negative 25 plus 12k over 12 needs to be greater than 1. Needs to be less than negative 12. I'll times the negative 12 to the other side. Remember to swap the sign. So 12k is less than negative 37 minus the 25. So k is less than minus 37 over 12. Okay, you're solving for the minimum value to be greater than 1. If that is greater than 1, all the rest of the points needs to be above that level. So we look at key points. Okay, it's very important to think about the key points. It's just, it won't ask you, okay, for a linear, I want a minimum value of 1. You can't achieve that. Okay, so that's, but for quadratic, there will be a minimum point. If you can make the minimum point above that level they required, then all the points will be satisfied. Okay. So we have negative 27 over 12. K is less than that. Do you have any question you want to ask for that one? That's a really good question and really important question. Okay, so we need to exactly know what we're doing here. We need to complete square because we want to find the turning point. When you're trying to do complete square, there's a lot of traps you need to pay attention. And after we find that, we are going to talk about the minimum value for the whole graph. Okay, so if we make the minimum value all above one level, then all the rest of points will satisfy as well. Okay, if you don't have any questions, we'll stop here today. After the swimming, we will keep going for chapter 4. Okay, we'll go for chapter 4. We stopped chapter 5 for a while, we finish chapter 4, and then we come back to chapter